What's up guys, my name is Mike, I am a software engineer, algorithmic Forex trader, and recently I live in Thailand as an expat. So for those who are new to this channel, if you are interested in algo trading, feel free to subscribe to this channel down below and join our Discord group to exchange ideas about Forex trading, algo trading. And now let's move to the main topic of this video, which is me sharing my journey on building proper software for latency, arbitrage, algo trading. So let's start when we stopped last time. In the previous video there was a lot of coding stuff going on. I had entity designs ready in draw.io diagrams, so it was final time to implement the designs into real code. For the implementation, first I created all the interfaces for all the necessary entities listed in the diagram. Then the next step was to create unit test for this project, because accordingly to test-driven development, you always need to first develop tests and then the business logic implementation. I managed to write over 200 tests for the domain project, and all of them in the end passed after doing the implementation. I thought it would take me around 1 day, but it took me almost 5 days, but it is finally done. Okay guys, so we have the service project, which is responsible for talking to our frontend via gRPC. We also have the domain project, which stores all the entities that exist in the trading domain. So now we need to somehow glue this together. And there is also one more thing that is missing, and it's crucial for any HFT trading system. We still do not have the design of the hot path of the entire application. So the processing pipe where the low latencies will be crucial. So this is the data processing pipe where the low latencies will be crucial. That's the place where this no memory allocation programming actually happens. So for those tasks, I am going to use the .NET Disruptor library, which is the port of the LMAX Java Disruptor library to .NET environment. It can be found on GitHub if you do a little Google search. So I decided to use this library as LMAX is one of the fastest exchanges out there, and they are using their disruptors patterns in their matching engine. So I thought it would be a good reference point. Okay, so let's think right now about the project structure. We need to connect to the exchanges, right? So this will be our core of our application. So the libraries that are responsible for connection to, let's say, fixed protocol or MetaTrader 4 or other difference. So these are like the core that connects to the external sources. Okay, so we will need, let's say, MetaTrader 4, MetaTrader 5, let's say we need also a fixed protocol. We also need a library to manage our threads. So more about this in the next few minutes of this video, but we will basically need LMAX Disruptor library. So let's put it here, thread library. Okay, so this is our core. So now on the next layer, we have our domain object. So basically all the entities in the trading domain that will use those connections. So whenever we add more connections to the market, there will be in the very middle, in the center of the reference pipe, on the reference diagram. So this is our domain project. So now what's on the top level? What do we have after the domain? What is using the domain object? Of course, we have the application object where we actually store our entire engine. So all the actions that actually to open the trade, to close the trade, to somehow interact with our entities objects will happen in our application project. So let's add another layer. So this is our application project. And then, of course, we have the services project that interacts with the application project and communicates with our frontend through GUI. So let's add this one as well. Services gRPC. And now, basically, this is like communication interface. So this thing, protofiles. So basically, this thing will interact with our GUI, with our front-end, by using objects defined in our protofiles. So here we can add, let's say, our GUI, and we can also add, let's say, API. If we want to add some programming access to our engine service, we can just use it. It's just simple API. It's not RESTful API, but it's using the gRPC, but the principles are pretty much the same. So that was the reference pie chart. And now let's focus on the trading process. We need to think decently on all the bottlenecks that can happen during the market data streaming, sending orders, and algo calculations. So first of all, let's pay our attention to exchange connection. We need one circular buffer for incoming market data stream. This buffer will prevent any bottlenecks when it comes to receiving data. When a new market data will be delivered to us, we just serialize it to our common format and put it into the buffer and then wait for another incoming market data, like this. So we're gonna update our buffer with new data, which is already full with pre-allocated objects. So you remember pre-allocated, so we built everything on the startup of the application. And we also will need another process on another thread that will actually pick up those market data and transfer it further to our system. So the next very important thing is trade data engine. We need to be able to send asynchronously multiple trades at the same time for one exchange without creating any queues with request-response communication and stuff. So for this purpose, we will need two circular buffers. Two. One buffer to receive orders request from our software, and the second buffer to update the incoming data from the exchange server. And I am talking right now about the order confirmation messages and stuff like this. So when we send the order, we got response whether we got filled with the order or the order was rejected, requoted, or any other stuff. And of course, one process on another thread will keep on sending the order from the order request buffer, and on the another different thread, we will have process that will keep on receiving server responses from the order requests and put those responses to the second buffer. With this approach, we can send like 10 orders before we will receive order confirmation for the first trade. We have defined so far only 3 circular buffers disruptors. So what's next? Now we will need to define the main disruptor circular buffer that will be our core, our heart of the entire application. So in fact, we will need few buffers for the core, but first let's define the main usage. Okay, so we have our connection. Let's say connection interface. This is the main interface we have. And in this interface, we have 2 engines. So we have the trade data engine and we have the market data engine, responsible for trading and streaming of the quotes. So let's call it market data engine and trade data engine. We need to somehow put all the operations with those engines on separate threads to do not do any bottlenecks. So we need to, let's say when it comes to market data engine, we need to add disruptor to receive quotes. So let's say we have the broker server, right? And we receive quotes, right? To our market data engine. So every time we receive new quote, we put it on the buffer, on the circular buffer. So let's call it market data disruptor, MDD. And basically here we will have on the other thread function publish to main, let's say market data disruptor. This function will keep on looping on this disruptor and will push data into other disruptor. And this one, this is, let's call it main market data disruptor. So this buffer is like the main buffer of the entire application. So just to give you understanding, let's say we have few connections to the brokers and each connection has their own disruptor with own thread. So basically every time one of those connections receive quotes, it's being put on their buffer, and then each connection is running publish to main market data disruptor function. So all the data from the connection disruptors will be pushed into the main disruptor, and basically this disruptor will have few functions on the loop. So first function will be to update data So this will be basically to update all the trades and stuff like this. Then check for open and check for close. So basically every time we receive new market data in our application, first we update all the objects with the fresh prices. Then we check all the strategies to if there are any criteria to open the trade, and then we check for close. So then we check if any strategy needs to close some trades, and then it's also pushing the data. So now what happens if we send check for open or check for close? We send order, right? So let's take this one and we push this to another buffer, which is, let's call it main trade data disruptor. So basically what this will do, basically it's the same thing like a main market data disruptor. So what it does, it will store all the requests to open trade or close trade, basically all the order requests. And then it will put this data into the trade data disruptor, which is, this disruptor, each I connection, each trade data engine will have this disruptor. So it's one per each connection. And basically then on another thread, we will have a function like send order. Okay, so let's make the quick summary of what we already got. So we will need 3 disruptors, circular buffers, for each connection to the exchange. 1 shared circular buffer to process market data from all connections with 3 handlers. 1 handler to update new quotes, 2nd handler to check for opening the trade, and the 3rd handler to check for closing the trade. We need also another shared circular buffer with handler to process all responses from order request and update the opened and closed trades for each connection. Did we forget about anything? Yes, so the thing that we forgot about is actually defining the entities for the algorithmic strategies. Those are very important as they make all the profits that we love. So the main purpose of creating this application is to actually make profit. For the strategies, we need, of course, the interface for access. And we need to create a repository object to store and manage our all strategies. So it's pretty much the same like with the interface for connection to brokers and exchanges. And each strategy should have, of course, the ID, the name, the bool flag to define whether the strategy is running or not, and of course, start and stop voids, start and stop functions are also needed to switch this flag that defines if the strategy is running or not. Strategies also need a list of all exchange connections and instruments to monitor and trade, but this property can be different for each strategy type. Some of them will need only access to 2 broker connections, and some of them will monitor all exchanges. I decided to do not include this data in the interface and implement this separately for each algo strategy object. Okay, so I think we have all the designs we need in order to start coding, but this will happen in the next episode of this video series. Let's try to keep the designs and implementation separately, as this is very important during any software development lifecycle, and creating software for trading is no different. Anyway, thanks for watching this video till the end. If you like this content, please hit the like button below and subscribe to this channel, as the growing numbers of subscribers helps keep me motivated to produce more content like this for you guys. And if you also like exchanging nice ideas about algo trading, forex trading, crypto trading, feel free to join our Discord community. The link should be also somewhere down below in the description. So without any more relevant info for me, see you guys in the next video.